Hi, my name is Devin, and I'm a support engineer here at Listen. Today, I want to show you some of the features of the limit steps in SoundCheck. A limit step compares data to a predetermined set of conditions, resulting in a pass or fail verdict that is output to the memory list. Within my limit step, I'm going to show the Parameters tab and some of the different options available. Under Limit Parameters, I have a drop-down called Alignment. Here in SoundCheck 18, I have 6 options available to me, and each is for very different purposes. Let's start with absolute limits. The exact numbers or values that you enter will be used to calculate the limit. Also, data between points is interpolated. If I set my upper limit from 20 to 20K at 100 decibels, SoundCheck will draw a line between the 2 points. And I can do the same for my lower limit and set it at 50 decibels. If I click Apply, it will show me the results of this limit step with the data I've inputted. I'm using the statistics curves, which are available in your SoundCheck folder. You can see the limit step fails because my data goes beyond my 100 dB limit. If I enter 2 points, SoundCheck will interpolate in between them and draw a line for my limit. I can also take data like a curve or a set of specific values from the memory list and use that as my limit. The most important aspect of absolute limits is that they do not change based on test data. Whatever points are entered, that's where they'll stay. If I choose individual points, these limit points still behave as absolute limits, but SoundCheck does not interpolate or connect the dots between them. If you only cared about data at specific points and did not want those points to change during testing, use this setting. Let's say I have a curve, and for this limit step, I'm testing to see if my low end is too high for my device to reproduce. I can set an upper limit individual point at 80 dB, and when I apply this limit step, it results in a failed state. This can be used to stop a sequence and prevent damage to your equipment. If you want to run a test that can adjust to different levels, floating limits are the best option. Floating limits are essentially an upper and lower limit with a set distance relationship to each other. If I have 2 points on my upper and lower limit, let's say at 110K, I can set my upper limit to be 20 dB and my lower limit to be 0 dB. Now, since floating limits can adjust and move to the data input, what I've created is a 20 dB window for my test. This is useful if you're expecting a certain response shape from your DUT, but the level on the y-axis varies. Floating data will behave with the same adjustment properties as floating limits. With floating data, however, the limits will stay at their defined location, and SoundCheck will move the data to best fit between the limits. Aligned limits and aligned data give me access to this field called alignment reference. This step will take my data and adjust it to the defined alignment values. Aligned limits is where an alignment reference x-axis point can be input manually. SoundCheck will analyze the data and find the y-axis point based on the x-axis reference point. With each subsequent test, the limits will move in conjunction with the data. If I test something with an amplitude of 95 decibels at my alignment frequency of 1K, my limits will move in reference to this point. Now, if I test another device with less than 95 decibels at 1K, maybe more like 90 decibels, my limits will move down to adjust to the lower reference point. Aligned data will move my data to a specific x and y coordinate based on my alignment reference values. The limits will not move at all. A useful feature of using aligned data is the curve it creates in the memory list. I can display the data on a graph or table, and it will be aligned with my reference points, but without altering the data itself. To show this, I'm going to build a quick sequence. I'm going to start with a simple stimulus, then an acquisition step, and an analysis step. And I'm going to edit my limit step to be looking at the fundamental. When I run it, you can see there's no data in my memory list for the fundamental and fundamental aligned. As you can see, it outputs the frequency response curve with 1K at 95 decibels. So during this work from home time, I hope you find these tips helpful as you continue to explore what SoundCheck can do. Be sure to check out our other videos in this work from home series. Thanks for watching.